In the previous video, we looked at a stack of Vega images captured with a star analyzer. In this video, we're going to stack a series of images. They're captured with a slit spectrometer this time. Even if you're using a star analyzer, this video will have a lot of helpful information for you. To get started, just like in the first video, I need to select the folder that contains the images I'm going to stack. I'll come over here and I'll select the ellipsis triple dots and then pop up the select folder screen. Now I want to make a quick editorial comment here. In all of the past releases, the screen where you selected folders from looked like this. Over the years, a lot of users had trouble using this screen because they couldn't find the folder or be sure that they were selecting the right folder because they couldn't see what files were in the folders. And our beta testers for the stacking feature, they encountered the same problem. They had trouble finding their image folders and were never confident that they were selecting the correct folder. So in this release of RSpec, we use a new select folder window that looks like this. As you browse, it shows you what files are in each folder so you can be certain to quickly find the right folder to choose. Okay, so I'll click on this button to climb up one folder, and then I'll click on this one, which has the data that I want to use in this video. Here we can see all of our FITS files. And I'm sure I've got the right folder, so I'll click on this button to select it and close the window. Back here on the stacking screen, we can see a list of all the files we're going to stack. Now, just a quick word of advice. See how these files are currently sorted alphabetically in ascending order from A to Z? You can click on column headings in the grid and change the sort order, but in almost all cases, that shouldn't be necessary. Why? Because I strongly encourage you to name your image files so that the file names sort chronologically. See how these images all end with a number with leading zeros? Your camera control software should do that for you. Why am I pointing this issue out? Because for good stacking results, it's important that you stack your images in the order they were captured. We'll see in a later video why that's the case. Okay, so now you recall from the Vega video, we have to select the base file that we want to use as our reference file. That will anchor all of the images when they get registered. So I'll double click on the first image here. Wow, what's this all about? Well, some of you will recognize that's the calibration lamp image that was taken at the start of this run. And clearly we don't want to include this image in our stack. Here's a new capability you haven't seen before. You can remove the check mark on any grid row to reject an image. There. Now that file won't be stacked. So let's move on to the next image, double-clicking it. We can see over here it's a little dim, so let's pop up our histogram stretch. One of the new features in this release is that the histogram stretch screen has a new checkbox. When it's checked, each image is automatically stretched at the time it's loaded. That way you're not down here adjusting things every time you load a new image. So when the image is stretched, we can see more detail from it. It's got a lot of emission lines, doesn't it? It's a wolf-free A-star. Notice this glow area over in the corner. This is likely amp glow from the camera or perhaps light pollution at the observing site. Over here on the profile graph, we can see the emission lines. Wolf-free A-stars have beautiful profiles, don't they? As we've seen, I can look for a good image by stepping through the images with these buttons or with the Control+ or Control- keyboard characters. When we work with spectra, image quality differences aren't always obvious at first glance. Try zooming in on a small feature like this absorption line to make subtle differences easier to spot. Let's go with this image. It's image 9. So I'll click on the reference button here to make it my base image, the reference image. Like we did on the Vega image, we could use the red capture box to select a region of interest, ROI, around any feature in the image, like that. The red capture box often does a great job on these images, but it's best on zero order stars, which we don't have here. And if this image didn't have any bright spectral features, we likely wouldn't have anything to put in the red capture box. And that brings us to this ROI field. Rather than using the red capture box to specify my region of interest, I'm going to use this option, the orange and measure lines. Let's see how that works. RSpec will use the orange lines for the two sides of the ROI box, the top and bottom. So that's here. And it will use the measure lines for the sides of the region of interest. Rather than having to drag the measure lines out to the middle of the screen from the edges, I can click on this new toolbar button here just to center the measure lines. There they are, centered on the screen. And I can drag them around this feature. Say like that. So we've specified the orange lines here and the measure lines here. So we have the four sides of our rectangular region of interest, just like the red capture box. One point about documentation here, when you see buttons like this one with a question mark, that means there's more information available. For example, when I click this button, it gives me the option to watch a tutorial video or to view the relevant page in the FAQ. Let's do that. The FAQ opened to a page that describes what I covered in this and the previous video. This is the red capture box that we used on Vega. And on the next page of the FAQ, it describes using the orange lines and the vertical measure lines like we're doing now. I hope you'll find this FAQ really helpful and that this kind of context-sensitive help will make the software even easier to learn. Okay, so now we're almost ready to stack. Let's go to the stacking options screen for a moment and make sure, like we did on Vega, that we have a check mark here. That way, RSpec will move the primary profile to the reference profile graph so we can compare the before and after profiles of the stack. By the way, you don't have to close the stacking options window. It's a floating window and we can just leave it floating out of the way. You might even drag it over to a second monitor. Screen real estate is in short supply, which is why it's a floating window. And see, it's even got a stack button too, so you can even initiate a stacking session right from there. Let's do that. While the RSpec stacking engine is working, you can continue to move around. Here I'll click in and zoom for a closer look. Okay, here's our stacking result in red. Oh wow. Look how much less noise the red stacked result has compared to the original reference image in blue. And if I zoom in, we can see features that were barely visible in the original reference image. And if I want to spread the two curves further apart, I can use this scaling tool from the toolbar. Notice there are a few more buttons on the scaling tool, including a reset button. This is really fun stuff to see how powerful stacking can be. The ROI you choose matters, but don't overthink it. Just look for a feature with a clean profile. You can always come back and change it. Let's try a few. I'll move the ROI over here. As usual, when I click the stack button, RSpec moves the red curve, which is our most recent stack, to the blue curve. There. The red curve is the new stack. See how little difference changing the ROI had? We got almost the exact same stacking results. And what about absorption features? How do they work? They work the same. Well, let's try one. The stacking worked here too. It's almost identical to the previous one. The best way to learn what works best is to just play around like I am. Leave the scale reference here open. It's at a very small percent. That way your red and blue curves will always be separated by a small amount, making them easier to read. I really encourage you to experiment just like I did with different regions of interest and see which give you the best stacking results with your own data. So whether you use an ROI with an absorption feature or an emission feature, or both, you've now seen how to use the orange lines and the measure lines to create a region of interest. So now that I've shown you how to stack with slit spectra, let's look a bit at how we can evaluate our results. I'm going to widen this window so you can see this column, which is ROI fit. What this number measures is how much each row's ROI matches the reference image's ROI. It's not an absolute quality measure, but it's a great way to track quality across your stack. The reference image is always set to 100. We can see that here. And we can see the other images have different ROI fit scores. The values here will vary depending on how big your ROI is, as well as your target object and the quality of your subs. The key here is that these numbers allow you to see if any of your images are so much worse than the other images that you should reject them. We'll see more about that in another video. But rather than dealing with these numbers in this column here, let's click on this plot button. The x-axis is the subframe number, and the y-axis is how many pixels the ROI drifted from the previous frame. The first frame here, by definition, had no previous frame to drift from, so its drift is 0. And you can see the subsequent frames each had a small but varying number of pixel drift from their preceding frame. The height of the points, the y-axis pixel movement, aren't integers because RSpec tracks down to the sub-pixel using a technique called cross-correlation. If the frame-to-frame drift is constantly high or suddenly changes, it might be the result of your mount or guiding software, or it might just be that the scene conditions were changing. Consistent frame-to-frame jumps of a few pixels like we're seeing here is not unusual. RSpec can tolerate much more jiggle and has no problem aligning the frames properly. Again, we'll see more of this in a moment and in an upcoming video. So let's add a little more information to the graph. I can superimpose a graph of the ROI fit numbers, the quality numbers that we saw in the grid. I'll click here to do that. On the quality axis, we can see that our quality hovers around the same value here, right around 98-ish. For image number 8, the quality is 100 because that was our reference image, so it got set to that. If the quality takes a nosedive on this line, that means it's a bad frame when compared to the reference image. So this is how you can evaluate the quality of your images. As I pointed out earlier, the stacking FAQ is really helpful. And here in the plotting screen, there's a specific button for that. Let's take a quick look. Okay, there it is. And you can read it when you need it. I just wanted to show it to you here. The final thing we're going to cover in this video is how RSpec decides what name to give the stacked output file and where does it put the file. We've seen the file names and the folder names here in the title bar, but how does RSpec decide which folder and what file name to use? So let's go back to our favorite screen, the stacking options screen. Here's where you can specify the name of the stack output file and whether it should have a date time appended to it or just a unique serial number. For example, if you wanted RSpec to give your stack output file a more descriptive name, say Star Party Wednesday night or some sort of description, you'd type that in here. So that's how the files themselves get named. Into what folder does RSpec save them? So the too long didn't read answer is in a subfolder in your images folder. And here's a quick aside. Sometimes this box isn't wide enough to see the entire path. If you hover your mouse over it, this balloon help displays the full name. And maybe you've noticed that the balloon help is easier to read in this release, right? The font's larger. This button, which we haven't used up till this point, will open the current folder in the Windows Explorer. I'll click on the button. So now we're in the Windows Explorer. Here are all the sub-images that were captured back in August. And here's the folder where the stack output goes. It always has that name. Let's open it. Okay, there are all the stacking output files that I've created in this data set. And of course, you can copy or delete any of these files anytime you want. Okay, now to finish up this video, let's take one last look at our stacking checklist in the FAQ because it's changed. I'll click on the FAQ button and go to the last page this time. Now that you've seen this video, I can show you the full checklist. There's a new step to select your ROI type, and the Enter ROI checkbox has another bullet here. So okay, with this video, we've now completed the heavy lifting for stacking. In the following videos, I'll show you some additional case studies and some of the other features that we haven't covered yet.